Welcome to lesson 3.6, Prove theorems about perpendicular lines. So the first theorem that we're looking at in this lesson is theorem 3.8. And that theorem states if two lines intersect to form a linear pair of congruent angles, then the lines are perpendicular. So if we break that down a little bit, if two lines intersect to form a linear pair, so we know linear pairs add to 180 of congruent angles. Well, a linear pair is two angles, so if two angles are congruent that add to 180, both are 90 degrees, so it would make sense that those lines are perpendicular. Theorem 3.9. If two lines are perpendicular, then they intersect to form four right angles. So all four of the intersections of those two lines are right angles. And then we have theorem 3.10. If two sides of two adjacent acute angles are perpendicular, then the angles are complementary. So in other words, we'll look at that one down here with C. But we know the angles being complementary means that the sum of the angles is 90 degrees. And the two sides of two adjacent acute angles are perpendicular. They are referring to the two exterior sides, not the interior shared side. So, example 1 helps us visualize these three theorems. So it says, write the theorem that justifies the statement. So in this first image here for A, we have angles 1, 2, and then the right angle down here. Well, what we know here is if this is a right angle, then it's a vertical angle with 1, making that a right angle. 1 and 2 are linear pairs, so that's a right angle. And then the vertical angle there is also a right angle. So 4 right angles. And if we know 1 and 2 are right angles also up here, which was established, then we can say the bottom 2 are right angles. So either way, 4 right angles. So that would be theorem 3.9. Two lines are perpendicular. They form 4 right angles. In B, we're told R is perpendicular to S. And then if we look, we have angles 1 and 2 with the single arc symbol in each, meaning they are congruent. So in this case, if we have theorem 3.8, two lines intersect to form a linear pair of congruent angles. So here's our linear pair along line S. Line R intersecting it at angles 1 and 2. 1 is congruent to 2, so those two are congruent. Then we can state R is perpendicular to S. So theorem 3.8. And then we are trying to state that angle 1 and angle 2 are complementary. Well, angle 1 and 2 are adjacent angles. The exterior sides of the adjacent angles are 90 degrees right here. They're perpendicular. So then we know angle 1 and angle 2 are complementary, meaning angle 1 and 2 add to be 90 degrees. So that'd be theorem 3.10. So if there's a perpendicular line, the two interior adjacent angles are always complementary. So in example 2, we're going to explore that idea and find the measure of angle 1. So we have a perpendicular angle here and then 75 degrees. So we can simply do 90 degrees minus the 75 degrees to get the measure of angle 1. So the measure of angle 1 was 15 degrees. In B, we have angle 3 and angle 1. And then over here, we have a 90-degree angle. Well, we know if these lines are perpendicular, all 4 angles are perpendicular. Or we know 1 and 3 are a vertical angle to the 90 degree here. So we also know 1 plus 3 are 90 degrees. So then what we could solve to find angle 1 would be 90 minus the measure at angle 3 equals the measure at angle 1. But we don't know the measure at angle 3, so that's as far as we can take this to find the measure at angle 1. We could just give the equation. The measure at angle 1 equals 90 minus the measure at angle 3. And then in C, if we look at C, we know that we have vertical angle from 60 over to here, so this angle here is also 60. And then we know angle 1 plus that 60 is a right angle, so we can do 90 degrees minus the 60 degrees to get the measure at angle 1, so the measure at angle 1 is 30 degrees. Now we're going to explore the next two theorems about perpendicular lines. Theorem 3.11 says perpendicular line, or it's a perpendicular transversal theorem, says if a transversal is perpendicular to one of two parallel lines, then it is perpendicular to the other. So if a single transversal is perpendicular to one of two parallel lines, then it is perpendicular to the other. So if I look down at this diagram, if I told you lines M and N are parallel, and if S was perpendicular to N, then S is also perpendicular to M based on the perpendicular transversal theorem, because S is the transversal of lines M and N. So if we knew M and N were parallel, then S being perpendicular to N means it's also perpendicular to M. And then we have theorem 3.12 or 3.12, that's lines perpendicular to a transversal theorem. And there is a typo there, it should read in a plane. So in a plane, if two lines are perpendicular to the same line, then they are parallel to each other. So if we look at lines R and S here, R and S are both perpendicular to line N, so we could say R and S are parallel to each other. So then if we look at example 3, we're actually going to look at that as one of the three parts. So it says, use the diagram to the right, explain why or why not. So the first one says, is R parallel to S? So yes, they are, because R and S are both perpendicular to N. So then R is parallel to S by theorem 3.12. Next question, part B, is M parallel to N? So is M here parallel to N? Yes, it is, because lines M and N are both perpendicular to R. So M and N, both perpendicular to line R. So we could say M and N are parallel by theorem 3.12. And then is R parallel to T? So we have R here, T here. So are those two lines parallel? Well, we don't know anything about T other than it crosses M and N. We don't know anything about the angles. So in that case, R being perpendicular to M and N doesn't help us know anything about the angle T meets them. So we could not answer that at this point, or it would be unknown. So at this time, we would say no. Then we get to example 4. It says find the value of x if line RS is perpendicular to line ST. So line RS perpendicular to ST. So in that case, again, we know perpendicular lines create four right angles. So we know 2x plus 20 degrees is a right angle, so 90 degrees. So we can set that up, 2x plus 20 equals 90. Solve for x by subtracting 20. So 2x equals 70. Divide by 2, and x equals 35. Then in part B, we have the same situation, perpendicular lines, so 2x plus x is a right angle, or 90 degrees. So we could set that up with the equation 2x plus x equals 90 degrees. 3x equals 90 degrees. Divide both sides by 3, and x equals 30. Then we get to the final idea and the final example. So the final main idea for this lesson is that the distance from a point to a line. So if we have a random point, point A, and a line K, the length of the perpendicular segment from that point to the line is the shortest distance between the point and the line. So the shortest distance from A to anything on line K would be at point B along that perpendicular. So the distance AB would be the shortest distance from A to that line. And then we get into example 4, which is using some of our reviews from previous lessons and some of the ideas from this lesson about perpendicular lines. So what it says down here is a partial map of a town is drawn on a graph where units are measured in feet. Line HL represents Main Street. So we have line HL here representing Main Street. Line CM represents 4th Avenue. And then point L is the library. Point C is the center of town. Point H is the high school. And point M is the media center. So part A wants us to find the distance from the media center to the high school. It doesn't say anything about traveling along the roads, so we can simply find the distance from the media center to the high school by either counting along the horizontal line here, or using the grid to subtract. The media center along the x-axis is at 900, high school is at 200. So 900 minus 200, they are 700 feet apart. Or you could count from H to M, 100, 200, 300, 400, 500, 600, 700 feet. In part B, it asks how far away is the medical center from the town center, or center of town, along 4th Avenue. So the medical center and the town center of town, how far away are those? So now we have 2 points along a line, and the only way that we can find, well, not the only way, but the most efficient way that we know of at this time to find that distance is to use the distance formula. So remember, our distance formula from our earlier chapter is the change in the x values to the second power plus the change in the y values to the second power, all in the square root. So it's the square root of the change in the x value squared plus the change in the y value squared. So in order to find this distance, we need to take the coordinates of the town center, which is 500, 600, and the media center, 900, 300. Put those in for our x and y values in the distance formula. So our x values 900 and 500, y values 300 and 600. 900 minus 500 squared plus 300 minus 600 squared. So we have 400 squared plus negative 300 squared, or 160,000 plus 90,000, and that's all still inside the square root, giving us the distance equals the square root of 250,000, which equals 500 feet. Then we get to part C. What distance do you walk if you go from the medical center to the library along 4th Ave and Main Street, round to the nearest foot. So what we know here, so not media center. Don't know why I wrote media center, medical center. My apologies, I just noticed that in the graph. So from the med center to the town center, we just did in our last one, medical center to town center. So the med center to town center, we know that distance is 500. So our total distance was that distance along 4th Ave, and then from the town center to the library on Main Street. So we need to figure out this distance of the town center to the library. So again, we're going to use those coordinates in the distance formula. So we know the library's at 700, 800, town center's at 500, 600. And we're going to plug that into the distance formula. So change in x values, 700 minus 500 squared, plus change in y values, 800 minus 600 squared. Both are 200. 200 squared is 40,000. So 40,000 plus 40,000 means our distance is the square root of 80,000. So our distance, rounding that to the nearest foot, is approximately 283 feet from the library to the medical center, or to the town center. So then that distance of the library to the town center plus the distance of the medical center to the town center will equal our total distance of 783 feet. And then the final part, part D, is asking if 4th Avenue is perpendicular to Main Street. So now in this case, we want to go back and use the slopes of the lines in our rule for perpendicular lines. And remember, that is, if the two slopes multiply to be -1, then the lines are perpendicular. So we want to find the slopes of both lines. So we can choose any 2 points off of 4th Avenue and Main Street. So I'm using these 2 coordinates off of 4th Avenue and these 2 coordinates off of Main Street. So we're going to put those in for the slope. So for 4th Avenue, 600 minus 300 over 500 minus 900, giving us -300 over 400, or a slope of -3/4. With Main Street, we have 600 minus 300 over 500 minus 200, or 300 over 300, which gives us a slope of 1. If we multiply those two slopes together, they do not equal -1, so we know those two roads are not perpendicular.